Hello, this is Sean McLaughlin from Education Analytics. This is the second video in a series that Education Analytics is doing regarding how our team creates value-added results for use in New York's annual Professional Performance Review, or APPR, based on the NWEA MAP assessment. In this video, what I'll be covering are a number of frequently asked questions, and a few are below just to give you a sense of what this is going to be about. First of all, we're going to be going over how is your MAP value-added score determined. We're going to be talking about which students are you linked to, as well as how does your value-added result turn into a 0 to 20 score, as well as a few other frequently asked questions that we've been including here. First off, I'm going to go over an overview of how your MAP value-added APPR score is determined. The first step that Education Analytics does is, after spring testing is completed, Education Analytics collects student data from participating districts across the state, and EA determines demographic and other adjustments for use in our value-added model. And if you're new to value-added models, I would recommend that you look at the first video in this series. What that does is gives you a little bit more background about how our value-added methodology works in the context of a oak tree analogy that is good at its introduction of explaining how the methodology works and then linking it back to education. So if you haven't watched that, please do. The second step in the process is Education Analytics makes a customized statistical prediction for each student based on his or her characteristics. So what we do is we have that fall test score for each student, and then we look across the state after spring testing has completed. We make sure we can get a customized prediction for each student based on his or her characteristics. That includes the average growth for similar students that had that same starting score, as well as adjustments for the test window, meaning the duration between the fall and the spring test. Districts test at different times during the year, so we make an adjustment for that. There are also adjustments if we find that different students in different demographic groups tended to grow faster or slower across those districts for which we've collected data. That includes the gender, race, ethnicity, English language learner status, free or reduced lunch status, and special education status of students. So what that does is we create a statistical prediction of each student at the end of the year, and that's customized based on the characteristics of each student. The third step that we do is we then look at the actual test score of each student in the spring of each year, and then we find out if each student exceeded or did not meet that prediction, and by how much. On the left, we have an example of the actual score for a student being higher than that predicted score. Again, that predicted score is customized for the characteristics and starting point of this particular student. In this case, that student's actual score was higher than we predicted, meaning the student exceeded their prediction by 5 points. On the right, we have an example of a student with again a predicted score that's based on his or her characteristics, and then the actual score was lower than that predicted score, that statistically predicted score. In this case, the student did not meet their prediction by 4 points. So after we've done that for every student, what we do is we gather it together for each teacher, or if we're doing a school analysis, each school, and then find out, did each teacher's students on average tend to exceed or not meet their predictions, and by how much? In this way, we're finding how much value did the teacher add to the student's growth. So over on the left in Teacher A, we can see that those arrows that are green and pointing up, meaning those students beat predictions. They exceeded those statistical predictions. And the orange arrows, what that represents is a student that did not meet the statistically predicted growth. In this case, on average, in that classroom for Teacher A, students tended to beat their predictions by a little over 3 points. What that tells us is that teacher had above average value added. On average, those kids tended to exceed their predictions after we controlled for all these different things, including the starting point of the kids, the demographic characteristics of the students, the test window between the fall and the MAP score, the instructional days that were occurring between those two periods of time. So after all those adjustments, those students tended to beat their statistical predictions. That tells us that the teacher had an above average value added. On the right, teacher B, we can see, just by looking at those arrows, we can see that those students did not tend to meet their predictions. If we average all that out, it's a little bit below what we would have predicted statistically based on similar students in districts across the state. What that tells us is that teacher has below average value added. It does not mean that these students lost knowledge. It means that they did not grow on pace with similar students from across the state. Finally, what education analytics does is it applies its result and converts it to the 0 to 20 translation for APPR using the New York Advisory Council's default translation. And that translation was a collaborative effort by district leaders and other folks across the state, as well as NWEA and Education Analytics, to get to that 0 to 20 translation. Here we have 4 teachers. For example, Miss Johnson over on the left, her students tended to not meet their predictions by wide margins. She would have a score that's lower in the 0 to 20 scale. Mr. Jones, his students ended up not meeting prediction by just a little bit, so he would have a score that's a little bit below 13. Mr. Harris, on average, his students ended up evening out, just meeting prediction on average. That would give Mr. Harris a score of 13 on the 0 to 20 scale. And Ms. Smith has an example of a case where, on average, her students tended to beat their predictions by quite a bit. They exceeded predictions, so she's going to have a score that's above 13. So that was the broad overview of how our project works, how we use data to come up with these value added and then 0 to 20 scores. I'm going to go over a few frequently asked questions that we get. One is about which students am I linked to? So what happens is EA receives your district's Student Information Repository System, or SIRS, data, and we use that to determine which teachers taught courses designated as math or reading and ELA based on the state course code. So here we have an example of teacher A being linked to a course that might be math or reading or ELA. We also, in that SIRS data, receive a list of the students who were enrolled in those courses and for how long. So here we have a few students that were linked to that math or reading or ELA course, as well as the length of time that that student was enrolled in that course. In that way, at Education Analytics, we can make adjustments for students that were only there for part of the year or who were there for the whole year. So we take that into account and we make adjustments for that. I want to note here that the NWEA class roster files are not used for this analysis. We had a good discussion with NWEA as well as the Advisory Council about the benefits or drawbacks of using those class roster files, and we decided that it would be better to use the SIRS data that the district collects and submits to the state for use of determining for APPR which teachers were linked to which students. It gives us a better sense of the time periods that were involved, as well as implying instructional responsibility for those teachers of those students. Next question is about whether NWEA growth targets are used. So what are these growth targets about? The ones that you are probably more used to are the ones that come from NWEA. They are the creator of the MAP test, and they generate national growth norms and targets for students based on their pool of data across the country and across multiple years. Their growth norms are not designed for accountability metrics and do not take into account the context of your specific classroom, thinking about the characteristics of your students, that the window between the tests, the instructional responsibility of yourself on those students, demographic characteristics of the students. None of that is included in the growth norms. Therefore, these norms are not used as part of the value-added analysis that Education Analytics performs. Instead, what we do is Education Analytics collects data from across participating New York districts in order to create a customized statistical prediction for your students based on the growth of similar students across the state to be used in an accountability framework, in this case APPR. Those are the statistical predictions that we explained a little bit earlier that take into account all those different adjustments that we would make for how your students would perform on the spring MAP assessment. What does statistical prediction mean? So a statistical prediction that Education Analytics produces is created using a statistical model at the end of the school year. These are not predictions that you're going to get ahead of time for particular students. A statistical prediction means something of finding out on average how did similar kids grow across the state based on participating districts, and then that prediction is how we would predict your student would have done under an average teacher's care across that consortium of districts. A statistical prediction is based on the outcomes of students across the reference group with similar characteristics, with adjustments for the fall MAP test score of a student, the MAP testing window between the fall and spring score, the instructional minutes, gender, race, ethnicity, English language learner, free reduced price lunch status, and special education status. A statistical prediction is designed to create an apples-to-apples measurement of an educator's impact. And now a few things that a statistical prediction is not. It is not an NWEA growth norm or NWEA student target. Those are different. It is not available at the beginning of the school year. We need to have at Education Analytics outcomes for similar students available in order to make comparisons. It is not a way to set a growth expectation for a particular student. Next, how does EA determine demographic adjustments? So I've been mentioning so far all these different adjustments that we make. Here's a little more information about how we go about determining that. EA uses real data from across participating New York districts to measure growth trends. We want to figure out, did students with certain characteristics tend to grow faster or slower? In this example, we're looking at non-special education students and special education students across a sample. And this is just hypothetical. We would use a statistical model to separate how did the non-special education students do on the assessment in terms of growth compared to special education students. And we might find in this hypothetical example that non-special education students tended to grow 1 point faster than the average for all students, and that special education students might tend to grow 6 points slower than the average for all students. So in this way, we're using statistics to separate out those students and then find out on average that they tend to grow faster or slower than the average for all students together. So in this case, we want to find out by how much, and then we're going to adjust our statistical predictions for students to level the playing field for teachers serving different student populations. The adjustments are not a set percentage for each characteristics. We are analyzing real data from each year to inform our adjustments. So, for example, we don't have a set policy that says, for example, we're going to make a 5% adjustment for special education students. What we do is we look each year at these different groups of students and then use our model to determine did the particular student groups grow faster or slower. And then we're going to adjust our statistical predictions for your students to take that adjustment into account. Next question is, how does my value-added result turn into a 0 to 20 score? New York's Annual Professional Performance Review, or APPR, requires that teachers receive scores on a 0 to 20 scale. Based on guidance from the New York Advisory Council, Education Analytics produces a default translation of its results to the 0 to 20 scale for use in APPR. How does that work? So in the default translation, if a typical teacher with typical value added, what would happen? They have students that are just meeting their predictions. In this case, we have a teacher with a couple of students who beat their predictions. They exceeded them by 4 points and 2 points. And then a couple of students that did not meet their statistical prediction. And when we average all that out, it turns out that we get a result that those students exactly met their prediction. In this case, we give that teacher a 13 on the 0 to 20 scale. A teacher whose students on average meet their predictions will receive an APPR score of 13, the middle of the effective range. That's based on the Advisory Council's recommendation on how to do the 0 to 20 translation. What about a different teacher? In this case, a teacher with below average value added was meaning that their students did not meet their predictions by various margins. In this case, a teacher whose students on average did not meet their predictions will receive an APPR score below 13. On the other hand, a teacher with above average value added, where a teacher whose students on average exceeded their predictions, will receive an APPR score above 13. And by how many points students exceeded or did not meet their statistical predictions results in how far away from average, how far away from 13 that score will lie. How did that turn out in our analysis here in New York. In a typical analysis year, this is the approximate distribution of scores teachers receive using education analytics method of the default translation. 79% of teachers end up in the effective range. About 10% of teachers end up in the highly effective range. About 10% are in the developing range. And about 1% of results end up in the ineffective range. This varies a little bit across years, but this is typically what we find using our methodology and the default translation. Next question, can I, as a teacher, calculate my value-added score? The answer is no. An individual teacher or even a district administrator will not be able to recreate an APPR score using the same methodology that education analytics employs. And why is that? First of all, EA's method requires student-level data from a pool of school districts across the state. We need, in order to do the analysis that we laid out here, we need fall and spring test scores for those students across those variety of districts. We also need demographic characteristics of those students to determine trends and adjustments. So, for example, we need to know the special education status of all those tens of thousands of students from across the districts that are signed up for this service. So that's required in order to make the same scores. Additionally, Education Analytics implements a series of complex business rules that interpret MAP test scores and SIRS data in order to make this analysis happen. We apply adjustments for student demographics, fall test, spring test windows, as well as other different factors to let us know how to interpret that SIRS data correctly. That lets us know how we want to link students to teachers in tested content areas. And if you're interested, those rules that we use for SIRS, SIRS data to determine which students are linked to which teachers, those are available up on our website if you want to look at those, how we use those test fields. Additionally, Education Analytics employs advanced statistical modeling to use to determine each teacher's effect. We have things like measurement error correction that is going on. We use a multivariate linear regression model to use to get our value-added results. We also do some post-analysis things like small sample size correction. So all these different things add up to a methodology that is robust to figure out value added for different teachers, but it also creates a barrier in that teachers and even district administrators don't have access to all these data in order to recreate these results. So how did we come up with this methodology? What happened was the APPR method employed by Education Analytics was co-developed with an advisory council of included representatives from participating New York school districts, NYSET, Education Analytics, and the Northwest Evaluation Association. So we came together over a number of years, and we've been getting better and better over the years at getting various improvements to the way that we do this, the ways that we interpret SIRS data, to come up with a methodology that is robust and statistically sound and gets those 0 to 20 results in a way that was agreed upon by this advisory council. For more information about how this metric works, we have some resources up available on our website that you can see the URL there. So please feel free to go on there, look at some other videos that we have available, some other resources, such as how we use the SIRS data, that's up there. You can also find some other contact information from us up there. So thank you.